Greetings to all of us. Assalamualaikum, Om Swastiastu, Namo Buddhaya, greeting of virtue. We are from group number 1, and my name is Christopher Daniel Siswanto, and my friends are Velicia, Fabianus, Dicky, and Shearly. On this occasion, our group would like to present the facility layout project as a project assignment from Tata Letak Fasilitas course. Next, OPC or Operation Process Chart is a diagram or a chart that describes the process steps that experienced by raw materials from the first operation until they become a complete product. In the operation process chart is written all the operational activities, inspections, and storing goods to the warehouse process. In OPC, operators can get information related to the time required for each activity, the material used, the size of the material, and what places or machines will be used to process the material. In OPC, there are 5 types of symbols used to provide and describe each activity, namely circle, square, arrow, half ellipse, and inverted triangle. The circle symbol shows the operational activities that occur when the process of changing object comes up with machines or other tools. The square symbol indicates the inspection of objects, and the arrow symbol shows the activities of moving or mobilizing workpieces and the workflows. The half ellipse symbol shows the delay or waiting activity where the material is still waiting to continue to the next process, while the inverted triangle shows the workpiece storage activities in the warehouse. And as you can see in this slide, there are 6 components that need to be manufactured, and the operations will be 34 operations, and there is one-time inspection, and then the process of putting the goods into the warehouse as the last step. And next. So in the second project, routing sheets are useful for determining the number of operators and machines that needed to carry out the production process for each shift. Starting from the forecast table, this is useful as basis for consideration in making decisions that related to the production of a product based on demand data. From the forecast results, we will get the unit per shift value that needs to be produced per shift. Routing sheet starts from the last operation of the OPC. This is because it follows the output value that has been determined from the forecast results, calculated from the final operation, because the input from the last operation can be determined, and then the input process becomes the output number of the previous operation, and so on until the first operation. Then calculate the time needed per shift for each operation by reducing the total time with machine downtime and the machine setup time. Then we get the number of machines by dividing the needed production time per operation per shift by the available production time per operation per shift. Then do the sum of all machine requirements according to the machine category. From the calculation of the machines needed, it can also be seen that the operator needed for each machine category. The number of machines and the operators needed are shown as we can see on the slide. And next will be continued by my friend.
Now, I'll explain about the third project. The purpose of this project is to know the space required in the production floor. First, we have to know the machine total area by multiplying its length and its width. Then we input the total area of largest component that ever input to that machine. The result of work in process is the total area of largest component that ever come out from that machine. For the total of operator is the amount of operator needed for each machine, because we use assumption that one workers only use 1 meter square. Then for total is the sum of total machine area, total product area, total result work in process area, and total operator. For the aisle area, the material is the same with total products area. The percentage of aisle we get from the aisle table. The total material aisle is get from the sum of total material area and result of multiplying total material area and percentage of aisle. For the operator is the same with total operator area. And we can get the total operator aisle in the same way with the total material aisle but this time we use total operator area. Next is we calculate the material flow by multiplying 2 with the sum of material area, total material aisle, operator area, and total operator aisle. Then we can know the total area for each machine, and we sum it up to know the space needed for the production floor.
So I will continue the presentation for Project 4, Form to Chart, and Project 5, Advanced Layout, but let me introduce myself. My name is Dicky Lerianto from Industrial Engineering 2018. In Project 4, what we are doing is calculating the load transfer between the operations in sequence. The calculation of load transfer between operations is categorized in three different conditions, namely the component table for operations that are component manufacturing with circle machines and radial arm saw machines. Then the second category is the assembly table for assembling operation on the assembly table. And the third is the finishing table for load transfer activities between finishing operations such as smoothing, paint, and after being grouped according to three different conditions, the displacement weights are recapitulated based on each machine to find out the total load for each machine starting from the circle machine, radial arm saw machine, assembly table, planer machine, water spray boot machine, and jointer machine. From the recapitulation of the total load for each machine, then process with iterating to get the order of minimum machine weight per shift. In the fourth iteration, our group gets a minimum weight of 2629.3833 kilogram per shift. As you can see in the slide, the result is coloring with color blue, and the best machine sequence are from storage next to circle machine, next to radial arm saw machine, next to jigsaw machine, next to water spray board machine, next to assembly table, next to jointer machine, and ending at planer machine. So I will continue to present about Project 5 Advanced Layout. In Project 5, it is related or ongoing from Project 4. After in Project 4, we get a sequence of machines and the load size, which is the minimum load per shift. Then in Project 5, with the help of Lingo software, we can get the area of each machine and the total area of the production floor that the company needs. As you can see on this slide, the production floor area is 28 meters long and 38 meters wide. With the arrangement or layout of the engine as shown in the slide, then the machine's cycle machine is 9 meter long and 2 meter wide. Radial arm saw machines area with a length of 29 meters and a width of 2 meters. The area of jigsaw machines is 17 meters long and 8 meters wide. The area of water spray boot machines is 10 meters long and 8 meters wide. The area of jointer machine is 17 meters long and 18 meters wide. The area of planer machine is 13 meters long and 4 meters wide.
Project 6, ARC. In this project, there are 15 areas where the location will be regulated, including the production floor, raw material warehouse, finished product warehouse, parking lot, office, locker, toilet, security post, health room, canteen, generator, lobby, showroom, meeting room, and also prayer room, or we call it a mosque or musola. There are 6 symbols in this form of letters which have different meanings, namely A, must be close, A, very important, E, important, O, just normal, X, not wanted, U, it doesn't matter. From this precedence diagram below, we can see the relationship between the proximity of one area to another, denoted by the letters of A, E, O, U, E, dan X.
Project 7. In Project 7, we can choose the location like the table that highlighted by purple that Banjarnegara is chosen. To choose the location, we using CFM, OFM, SFM, and alpha for counting the LM, with the alpha is 0.5, and there is the HPP. There is manufacturing cost consisting of direct raw materials, additives, labor, overhead, and material handling costs. And non-manufacturing cost is indirect labor and depreciation cost. For count the cost per shift and cost per product, and the amount is equal 403,125.28 rupiah per product.
Okay, so from Project 6, our group gets the overall plan or layout of the company, starting from the room layout, the parking area, personal requirements for company worker, material handling flow, and facility system in a company, and everything is realized in the form of 3D design using 5D Planner software. Uh, the length and width size as well as the room and the content requirements obtained from for the previous project are depicted in this 3D design in this slide. As you can see, this is the design of the musola of the company and the warehouse here, and we have lobby design and production floor design, toilet design. So here you can see in the design 3D design of our layout from warehouse, musola, security room, lobby, generator, and hospitality room, production floor. And after that, I will show the next. We have parking area and the office room for all office worker, and this is the showroom for our products to so the visitor can see, and we have meeting room here, and we have eating room for all the worker or canteen. This is the canteen, and we have meeting room here, and this design we have office room and parking area the for the motorcycle and all cars of the office worker, and this is the full layout of our company, and we design it in 3D design. So that's all from our group. That's the presentation of the entire facility layout project from group 1, and thank you for your attention.